Imagine holding an ancient rock in your hand. It looks ordinary, gray, rough, heavy with time. You might pick it up on a hike through quiet hills or find it exposed in a road cut. This rock has been part of the earth far longer than any human story. It has seen oceans come and go, mountains rise and crumble, forests bloom and burn. For generations, we have told ourselves that rocks like this hold only natural secrets. The slow dance of minerals, the buried shapes of long-extinct creatures, the quiet record of wind and rain and fire from the sky. But what if that rock holds something more? What if, hidden in its layers, there are faint traces of purposeful change, of fires deliberately lit, of materials carefully shaped, of a world once altered by minds that were not our own? What if the stone in your hand once formed part of a structure built by another intelligent species? A society that rose, dreamed, created, and then vanished long before the first human ever existed. What if we are not the first civilization to walk this earth? This is not a story of mythical lost continents or glowing crystals. This is a serious question raised by scientists who spend their lives studying how worlds warm and cool, how life spreads and fades, how planets keep their deepest memories. They look at old rocks, ancient ice, and strange patterns in the ground, and they wonder, if another advanced society had lived here in the distant past, when the world was warmer, wilder, shaped differently, would we even recognize what remained? Today, we will walk together through a hidden history of our own planet. We will follow quiet clues that most people never notice. We will meet moments when the world changed suddenly, in ways that feel strangely familiar. And we will face a possibility that shifts everything we believe about our place in time. Prepare yourself. The ground beneath familiar ideas may feel less solid by the end. We begin with two respected scientists who decided to ask a question few others had dared to voice clearly. One leads a major center that watches Earth's climate from satellites and deep records. The other explores how life and intelligence might appear on worlds beyond ours. Together, they published a careful study they called the Silurian Hypothesis. They borrowed the name from imaginary ancient beings in a beloved story, not because they believed in such creatures, but to highlight how far back we must look. A time when the land was arranged in unfamiliar patterns, when different kinds of life ruled the seas and forests. Their question was straightforward yet powerful. If an advanced society had existed here long ago and then disappeared, what signs would survive today? And would we know them when we saw them? They were not claiming it happened. They were testing the limits of our ability to read Earth's long, restless memory. To follow their thinking, we need to understand something essential about our planet. Earth does not keep perfect records. It is always moving, changing, erasing. Picture Earth as a vast ocean of rock that slowly flows. Old pieces of the surface sink into deep heat and melt away. New pieces rise from beneath the seas in long chains of fire. Rivers grind mountains into sand. Ice sheets scrape entire landscapes clean. Winds and rains wear everything down, layer by layer. Over immense stretches of time, nearly everything on the surface is reshaped or destroyed. A great city built today would, after enough ages, leave only the faintest echoes, perhaps thin bands of unusual materials in the rock, or brief shifts in the ancient air trapped in ice. Our own time is already writing clear messages into the planet. We have spread certain substances far and wide, thin fragments that do not break down easily, changes in the balance of gases from burning ancient buried fuels, unusual traces from our tools and machines. Anyone studying the rocks of our era would see unmistakable signs of deliberate, widespread change. But let those signs sit through countless cycles of burial, heating, erosion, and renewal. Most direct traces would fade, metals would rust and dissolve, built structures would crumble and vanish. Even strong materials would be ground to dust and scattered. What might endure are only indirect hints. Odd layers rich in certain elements, sudden warm periods preserved in ancient sediments, strange patterns in the chemistry of old oceans. The scientists realized something unsettling. If another advanced society had risen in the distant past, we would expect exactly this pattern. No grand preserved ruins, no obvious machines waiting to be dug up. Just subtle disturbances that we usually explain in other ways. And here the path becomes more intriguing. When we examine Earth's long story, we do find many such disturbances. There are moments when the world warmed quickly, with shifts in the air that resemble what we see around us today. There are layers of rock that hold unexpected concentrations of rare materials. There are times when oceans became starved of life-giving gases, or when vast numbers of creatures vanished suddenly. We have natural explanations for all of them. Enormous outpourings of molten rock from deep inside the planet, sudden releases of frozen gases from beneath the seas, great rocks falling from the sky. These explanations usually fit well, yet the scientists urged us to consider, how certain are we that natural causes always tell the full story? If an earlier society had burned buried fuels on a massive scale, or released powerful substances by accident or design, might the traces look almost identical to natural events? The difference could be extremely difficult to detect. When this idea first appeared, reactions varied. Some dismissed it as wild speculation. Others found it a valuable reminder. We might overlook important possibilities simply because we never thought to search for them. We feel confident we are the first because we see no obvious evidence of predecessors. Yet the careful reasoning shows that absence of obvious evidence is precisely what we should predict, even if predecessors once existed. In the years since, new studies have examined ancient materials with finer tools, better ways of reading tiny trapped bubbles, more precise measurements of old sediments, clearer views of deep rock layers. All have revealed subtler details. Patterns that once seemed purely natural now carry faint questions, small inconsistencies, quiet coincidences. Step by step, the ground beneath comfortable certainty begins to shift. What if some of those sudden ancient warmings carried a hidden artificial spark? What if certain unusual layers preserve echoes of deliberate extraction and use? What if we truly stand on the shoulders, not of giants from myth, but of forgotten builders whose works have almost completely returned to dust? As we continue, we will explore specific moments in Earth's deep past when everything changed dramatically. We will follow scientists into ancient warm periods, strange ocean deaths, unexpected enrichments in the rock record. We will see how separate clues can begin to weave together into larger patterns, and we will confront the deeper implications. If others rose and fell long before us, leaving only whispers, what does that suggest about the longevity of any civilization, including our own? The journey now opens wide. Vast landscapes of time stretch ahead, full of shadow and surprise. Stay close. The most thought-provoking discoveries are still to come. We stand now at the edge of a vast, quiet landscape of time. The idea has been planted. Perhaps others came before us, rose to great heights and then faded away, leaving only the faintest ripples in the ancient rock. The scientists who first framed this possibility did not stop at wondering. They began to map out what such ripples might look like, and where we might already be seeing them without realizing. Let us follow their path more closely. The two scientists, one guiding a center that tracks how our world warms and cools today, the other exploring the chances of life on distant planets, sat down to think through every step. They asked themselves, what would an advanced society do to a planet that we could still detect after immense spans of time? They pictured a society much like ours in some ways, one that learned to harness buried fuels. Ancient plants and creatures turned to oil and coal over ages. One that built vast networks of machines, factories, and cities. One that spread materials never found in pure nature, certain metals refined in great quantities, substances created in laboratories, wastes that linger strangely. Such a society would change the air. It would release gases that trap heat, warming the world quickly. It would alter the balance of elements in the oceans, making them more acidic, harder for shell-building creatures to survive. It would scatter tiny particles that block sunlight or reflect it back to space. Many of these changes would be brief on the scale of Earth's long life. A few thousand years of intense activity, perhaps tens of thousands. Then, if the society collapsed through its own mistakes, through natural disasters, through running out of easy resources, the direct marks would begin to fade. Cities would crumble under vegetation, then erosion. Machines would rust and break apart. Even the strongest materials would eventually yield to the slow grinding of ice, water, and wind. But some echoes would linger longer. The sudden warmth would leave its signature in layers of sediment forming at the bottom of lakes and oceans. The changed air would trap bubbles in ice that slowly built up in cold places. Unusual materials would settle into mud that hardened into rock, creating thin bands richer in certain elements than nature usually allows. The scientists realized that Earth's memory works in layers. Each new era buries the one before. What survives is often indirect, side effects rather than deliberate monuments. Now comes the part that makes the skin prickle. When they compared their predictions to what we actually find in those ancient layers, patterns began to appear. Not one single smoking gun, not a clear machine buried in old rock, but many quiet coincidences. Many moments when the world behaved in ways that match what an industrial society would cause. Consider warm periods in the deep past. There are several times when the planet heated up rapidly. not over millions of years, but in spans that feel almost sudden against the backdrop of geological calm. During these events, the air filled with extra gases that trap heat. Oceans grew warmer and more acidic. Vast numbers of creatures vanished from the seas and lands. These are moments we usually explain with massive eruptions from deep cracks in the earth, pouring out lava and gases over long periods. Those natural explanations fit well in most cases. Great floods of molten rock did happen. We see their remains today in thick layers of dark stone spread across continents. Yet the scientists pointed out something subtle. The speed and style of some warmings carry features that feel engineered. The gases released have balances that sometimes match burned fuels more closely than volcanic output. The acidity in oceans rises in patterns that suggest a concentrated burst rather than slow seepage. Of course, nature can produce concentrated bursts too. Frozen gases trapped under the seas can release suddenly when conditions shift. Great impacts from space can shake things loose, but the overlap is striking. One particular warm period stands out in discussions. A time when the world grew much hotter quite quickly. Forests spread toward the poles. Creatures adapted to heat thrived. Then, just as suddenly, things cooled again. The traces left behind include a sharp shift in the kinds of carbon preserved in rock. Lighter forms dominate for a while, the kind often linked to living things or to fuels derived from them. We see similar shifts today as we burn ancient buried plant matter. Again, nature has ways to produce lighter carbon. Plants prefer it. Swamps and shallow seas can concentrate it, but the coincidence invites pause. Another pattern appears in the oceans. There are eras when vast stretches of sea lost their life-giving gases. Creatures that needed those gases died in huge numbers. Shells dissolved. The water chemistry shifted dramatically. We call these ocean anoxia events. They happen when warmth slows the circulation of deep waters, or when extra nutrients flood in and fuel massive algae blooms that then decay and consume all the gas. Natural triggers abound: changing sea levels, shifting continents blocking currents, extra runoff from land. Yet if a society had released enormous wastes, perhaps chemical runoff from vast agriculture or substances from industry, the effect could mimic these natural triggers almost perfectly. Add in the enrichment of certain materials in rock layers. We find thin bands unusually rich in metals that societies like ours use heavily: copper, lead, rare earth elements needed for machines. Mining and refining spread these metals widely. Smelting releases them into air and water, where they settle into sediments. In our own time, we see such enrichments beginning already, even before full global industry took hold in some places. In ancient layers, similar enrichments appear around some of the same disturbance events. Volcanoes can release metals too. Impacts from space deliver them. Biological processes concentrate them. The timing, the way these enrichments cluster around climate shifts, feels synchronized in ways that raise eyebrows. The scientists were careful. They stressed over and over, these patterns do not prove anything artificial. Natural causes explain each one individually and often collectively. But taken together across multiple events, the repetition becomes harder to dismiss lightly. It is as if nature keeps repeating the same dramatic play, with the same props and timing, over and over through deep time. Or as if something else occasionally joined the stage. The scientific community responded with a mix of curiosity and caution. Many welcomed the fresh perspective. It forced everyone to think harder about how we distinguish natural from potentially artificial signals in old records. Others worried it opened doors to wild speculation. Without clear direct evidence, some said we should stick to known causes. Yet the discussion spread. More researchers began to look at old data with new eyes. Better tools became available, ways to measure tiny trapped gases more precisely, to map metal distributions in finer detail, to model ancient climates with greater accuracy. Little by little, the anomalies sharpened. One study examined bubbles trapped in ancient ice from cold regions. The balances of gases told stories of sudden releases. Another looked at sediment cores pulled from deep ocean floors, long tubes of layered mud preserving quiet histories. Patterns emerged that did not quite fit the standard natural stories perfectly. Small mismatches, extra warmth beyond what volcanoes alone predict, metal spikes slightly out of sync. None of these were dramatic enough to rewrite textbooks, but together they built a murmur that says, perhaps we have been too quick to assume every major disturbance was purely natural. Perhaps some carried a hidden hand. As we stand here, early in our journey, the picture remains blurred. We have no grand artifact, no undeniable signature. only questions that grow heavier with each new layer examined. Questions that pull us deeper into the past, towards specific moments when the world transformed in ways both familiar and strange. Moments that mirror what we do today, on a planet that may have seen it all before. The path narrows now. Ahead lie particular events in Earth's long story where the coincidences pile highest. We will walk toward them slowly, examining each clue under clearer light. The ground feels less certain beneath our feet. Something ancient may be watching from the rocks, or perhaps it is only the wind whispering through stone. We will see. The murmur grows louder now. We have seen the broad patterns, repeated warmings, ocean crises, unusual materials scattered in ancient layers. Separate clues, each with natural explanations, yet together they form a rhythm that feels almost deliberate, like footsteps echoing from a distant room. To hear those footsteps clearly, we must step closer to particular moments in Earth's long story. Moments when the world shifted dramatically, in ways that mirror the changes we cause today. Let us begin with one of the most striking warm periods in the record, a time when the planet heated up quickly, transforming landscapes and oceans in ways that feel eerily familiar. Imagine a world already warm, with forests stretching far toward the poles and great reptiles still roaming some lands. Then suddenly it grows even hotter. Palm trees appear in places that should be too cold. Creatures from tropical seas swim northward. The air fills with extra warmth-trapping gases. Oceans turn more acidic. Many small creatures with shells struggle to survive. This event left clear marks in the rocks and sediments, a sharp boundary where the chemistry changes abruptly. Lighter forms of carbon flood the record for a while. The warmth peaks, then slowly fades. Scientists have studied this moment intensively. They pull long cores from the deep sea floor, tubes of layered mud that preserve the quiet history of ancient waters. They examine fossil leaves and pollen trapped in old lake beds. They measure tiny shells of creatures that once floated near the surface. The picture that emerges is one of rapid change, not over millions of years, but concentrated in a span that feels brief against geological time. The standard explanation points to massive releases of frozen gases from beneath the sea floor. As the world warmed a little from natural cycles, shifts in Earth's path around the sun, or changing ocean currents, those frozen stores destabilized. Vast bubbles rose, releasing powerful heat-trapping gases. The warmth fed on itself, accelerating until balance returned. Volcanoes played a role too, pouring out gases over long periods. This story fits much of the evidence. The timing aligns, the chemistry mostly matches, yet small details nag at careful observers. The initial burst of lighter carbon appears almost too concentrated, as if a massive amount of plant-derived material entered the air all at once. The acidity in oceans rises sharply, then lingers in patterns that suggest ongoing input rather than a single release. Some researchers have noted that the overall signature resembles what happens when buried ancient fuels are burned rapidly and in huge quantities. Of course, the frozen gas releases can mimic this. They hold carbon from ancient life too, but the precision of the match invites deeper thought. Around the same time, we see traces of other changes. Unusual movements of creatures across continents, stress in land ecosystems, brief appearances of strange chemical compounds in sediments, compounds that break down quickly but leave faint echoes. These could all stem from the warming itself. Heat stresses life, changes migration, alters chemistry, yet the synchronization feels tight. Now layer on the material enrichments. In sediments from this period, certain metals appear in higher concentrations than surrounding layers. Metals useful for tools and machines. Some show signs of having been processed, distributed in ways nature rarely achieves alone. Volcanoes release metals. Warming can mobilize them from soils into rivers and seas. But again, the clustering around the disturbance raises questions. This warm period is only one example. There are others scattered through deeper time. Another dramatic episode saw even greater upheaval. Vast outpourings of molten rock covered huge areas of land. Gases filled the air. The world warmed severely. Oceans lost their life-giving gases across enormous depths. Most creatures in the seas vanished. Many on land followed. We see thick layers of dark volcanic stone preserved today, testament to the immense eruptions. The gases from those eruptions explain much of the warming and ocean crisis. The timing aligns closely, yet once more, subtleties appear. The carbon shift carries a signature that partially matches biological sources. The ocean changes happen in stages that suggest multiple pulses of input. Some metal enrichments peak slightly before or after the main volcanic layers. natural processes can produce pulses. Shifting conditions can fractionate chemistry in complex ways, but the pattern repeats, a major natural event with overlays that could fit deliberate large-scale disturbance. Move further back to times when the world was dominated by different life forms. Coal forests covered vast. Strange armored fish swam in shallow seas. Then another crisis, sudden warming, carbon shifts, ocean stress. Similar story, similar explanation, similar quiet mismatches. As researchers compile these events side by side, a larger picture begins to emerge. These crises are not random. They cluster in certain eras. They share common features: rapid carbon input with lighter signatures, ocean acidification and anoxia, brief metal mobilizations, ecosystem collapses followed by recoveries. Each can be explained naturally. Together, they form a template that matches closely what an industrial society would leave behind if it rose, expanded aggressively, overexploited resources, polluted on vast scales, and then collapsed. The collapse could come from many causes: climate runaway, resource depletion, waste accumulation, conflict, disease. The direct traces would fade quickly in geological terms. Cities reclaimed by forests, then buried. Machines corroded to dust. Only the planetary scale side effects would linger: the climate excursion, the ocean changes, the scattered materials. And those side effects would look almost identical to certain natural catastrophes. This is the heart of the unsettling realization. We have never systematically searched the record for signs that distinguish artificial from natural on these scales. We assume natural because that is simplest and because it fits. But the scientists who framed this hypothesis showed that the distinction might be nearly impossible after enough time has passed, especially if the society was not vastly more advanced than ours, if they used similar energy sources, buried ancient life turned to fuel, if they built with similar materials, if their wastes were similar. Their signature would blend seamlessly into the background of great volcanic episodes, gas releases, orbital shifts. We would see the crises. We would explain them naturally. And we might miss the hidden contributor. Recent studies have sharpened this view. Better tools allow finer reading of ancient sediments, isotopic measurements more precise, models of past climates more detailed. Some findings show carbon inputs that seem too rapid even for the largest natural releases. Others reveal synthetic-like compounds, molecules that require high heat or specific conditions, usually linked to deliberate processes. These molecules break down, but fragments persist in certain protected settings. None of these findings prove artificial origin. Each has potential natural pathways, but the accumulation weighs heavier. Researchers now speak cautiously of anthropogenic-like signals in deep time, not claiming predecessors, but noting that our own signature will one day look much like these ancient events. If we vanish and the planet recovers, future geologists, perhaps evolved from today's survivors, might study our layer and attribute it entirely to natural causes. A great volcanic province, a methane burst, an orbital shift amplified. They might never suspect intelligent intervention. This symmetry is profound. It means our confidence in being the first rests partly on the assumption that we would recognize predecessors if they existed. Yet the very processes that erase direct evidence also blur the indirect signals into natural patterns. The more we study, the more the boundary softens. We begin to see Earth's history not as a steady progression toward us, but as a cycle of bloom and crisis, recovery and renewal. Life rises in complexity, spreads, adapts. Occasionally, something triggers massive disturbance. Then life retreats, rebuilds differently. We have always seen intelligence as the unique endpoint. But perhaps intelligence is just one more bloom, one that can overshoot and trigger its own crisis. If that has happened before, the evidence is there, hidden in plain sight, disguised as nature. The path ahead leads to even deeper questions. What would such predecessors have been like? How long could they have lasted? What finally ended them? And most urgently, what does this suggest for us? The rocks hold their secrets tightly, but they are beginning to speak. Listen closely. The next voices may be clearer. We have traced the quiet anomalies through the geological record, those subtle enrichments and disturbances that align in ways that feel too coordinated to be entirely random. The great crises with their carbon shifts, ocean anoxia events, and sudden warmings all carry natural explanations that satisfy most researchers, yet the recurring overlays, the precise timing of metal mobilizations, the concentrated lighter carbon signatures, the faint traces of complex molecules, build a case that grows harder to dismiss as mere coincidence. These are not dramatic artifacts waiting to be unearthed. They are diffused signals, planetary-scale side effects that blend almost seamlessly into the background of natural upheavals. Yet when viewed together across multiple eras, they suggest the possibility of deliberate, widespread activity that once reshaped the world before fading away. To deepen our understanding, we must now explore these quieter traces more closely, the ones that do not announce themselves through catastrophe, but whisper of sustained, purposeful transformation. In certain ancient sedimentary layers, far from the dramatic boundaries of mass extinction events, researchers have identified thin bands where rare elements appear in concentrations and combinations that nature rarely achieves on its own. These include metals that any advanced society would extract in vast quantities for tools, conductors, structures, and machines. Elements like copper, lead, and others essential for harnessing energy and building networks. In our own era, we see these same elements spreading globally through mining, refining, and industrial use, settling into soils, rivers, and ocean floors in patterns that future geologists will recognize clearly. In the deep past, similar enrichments cluster around the disturbance periods we have examined, often in forms that suggest high-temperature processing or rapid distribution, as if released deliberately rather than slowly leached from eroding rocks. Recent studies using advanced analytical tools have revealed even finer details within these layers. Tiny spherical droplets of pure metal, cooled quickly from a molten state, embedded in sediments in ways that mirror byproducts from smelting or combustion engines today. Nature can produce such spheres through rare events like lightning strikes or volcanic activity, but their abundance in specific, narrow horizons that coincide with climate shifts and ocean changes, feels disproportionate, inviting researchers to consider whether industrial-scale activity could have contributed. Alongside these are traces of complex molecular chains that resist easy natural explanation, compounds with structures that require intense heat, specific catalysts, or synthetic pathways to form fragments that echo plastics, lubricants, or fuel derivatives. Although these molecules degrade over time, protected pockets in deep sediments or sealed rock formations preserve enough for modern instruments to detect repeating units or bonds uncommon in wild biological or geological processes. In ancient soils and lake beds from certain periods, pollen records and nutrient profiles show sudden booms in plant growth followed by sharp collapses, patterns consistent with large-scale land clearing, intensive cultivation, and subsequent soil exhaustion or abandonment. Fossil assemblages occasionally include bones with markings that defy simple predator or erosion explanations, precise incisions, bore holes, or removals that suggest extraction or modification. While most such anomalies yield to careful natural interpretations, a persistent minority resist, accumulating as quiet questions in the margins of research papers. When combined with buried features revealed by modern mapping technologies, vast circular depressions, linear networks, or grid-like patterns blurred by overlying sediments, these clues paint a picture of infrastructure long reclaimed by the planet, distorted beyond clear recognition, yet still faintly visible to those who know where to look. No single piece of evidence stands as proof. Each can be accommodated within natural frameworks, and responsible scientists always prioritize those frameworks first. However, the convergence of so many subtle deviations, all clustering around the same planetary disturbances, creates a shadow pattern that grows more defined with each new study. Researchers now openly discuss technosignature-like signals in deep time, not as confirmed detections, but as statistical anomalies worth systematic investigation. Teams are forming to compare these patterns across events, using sophisticated models to simulate what moderate or intense industrial activity would predict for carbon release rates, waste deposition, material cycling, and climate response. Early results show that several ancient crises align more closely with scenarios of hypothetical societal growth and collapse than with some purely natural baselines, particularly in the pacing of changes, gradual buildup followed by rapid peaks and declines. This accumulating perspective reframes Earth's geological and biological history as something more layered than we once assumed, a record not of steady natural progression occasionally interrupted by external forces, but of a dynamic system that has experienced multiple episodes of accelerated transformation, each followed by healing and renewal. If intelligent societies arose more than once, their influences would not appear as concentrated golden ages with preserved monuments, but as diffused pulses scattered across time, each leaving variations on the same theme: extraction and spread of materials, alteration of atmospheric and oceanic chemistry, brief intensification of planetary cycles, and eventual retreat. Different biologies, perhaps reptilian in warmer eras, avian in others, or forms entirely unlike our own, could have achieved similar technological thresholds, using available resources to scale their reach until natural limits or self-imposed consequences forced reduction. The implications extend profoundly into how we understand sustainability and longevity. If predecessors existed, their collapses, whether from resource depletion, waste accumulation, climate feedback, social fragmentation, or a combination, cleared the way for recovery, allowing life to experiment anew with complexity and eventually produce our own lineage. We inherit a world renewed after previous stresses, with abundant stored energy from ancient biology waiting underground, soils replenished, oceans rebalanced. Yet this inheritance carries an unspoken warning: the same abundances that fuel our rise once fueled others, and the same thresholds we approach now may have been crossed before. Our current trajectory, rapid extraction, global material spread, atmospheric warming, ocean acidification, mirrors the indirect signatures preserved in those ancient layers, positioning us within a recurring dynamic rather than at a unique pinnacle. As research advances, the conversation within scientific circles has evolved from cautious speculation to structured inquiry. New sediment cores from previously inaccessible depths, higher resolution isotopic analyses, and improved climate reconstructions reveal finer subphases within major events, multiple pulses of input suggesting attempted recoveries or shifting strategies before final tipping points. These details evoke societies grappling with mounting consequences, perhaps debating continuation versus restraint much as we do today, ultimately unable to reverse momentum in time. The absence of constant pollution across all geological eras argues against perpetual dominance by any single civilization, but supports the idea of limited, episodic rises separated by long healing intervals, each leaving only planetary-scale echoes that we have traditionally attributed entirely to natural causes. This realization humbles our sense of uniqueness while sharpening our awareness of choice. We are not the inevitable endpoint of life's progression, but potentially the latest in a series of attempts to achieve self-aware, transformative intelligence on this planet. The rocks preserve no judgment, only record, yet their repeating patterns feel like inherited knowledge, subtle maps of risk that predecessors lacked or could not heed. With modern tools and global communication, we possess something new: the capacity to recognize the cycle and deliberately step outside it, to manage energy flows sustainably, to innovate within limits, to prioritize longevity over endless expansion. Whether we exercise that capacity remains open, but the accumulating evidence from deep time makes the question impossible to ignore. The journey now carries us toward even broader implications, connecting Earth's hidden history to the larger cosmic context. If such cycles have occurred here multiple times, what might they suggest about life and intelligence across the universe? The great silence we observe from the stars, despite billions of potentially habitable worlds, takes on new meaning when viewed through this lens. Civilizations may rise frequently yet remain brief, their traces confined to home planets and erased by time, leaving vast quiet spaces between fleeting blooms. Our own moment, then, becomes not an anomaly of isolation, but a typical phase in a common pattern, one where awareness of the pattern itself offers a rare opportunity to extend beyond it. With the shadow pattern now more defined across the geological record, the converging anomalies of material enrichments, molecular fragments, land use signals, and buried structural hints all aligning with planetary disturbances that repeat through deep time, we find ourselves compelled to confront the human element in this story, to sketch the possible lives and fates of those who might have come before us. Not as mythical figures, but as plausible, intelligent societies, shaped by the same evolutionary pressures and resource opportunities that drive our own. These predecessors would have emerged in worlds configured differently from ours, with continents locked in unfamiliar superformations, oceans dominating vast hemispheres, atmospheres richer in certain gases or warmer overall, and ecosystems dominated by life forms adapted to those conditions. Perhaps great forests of scale trees under dimmer suns, shallow seas alive with trilobite-like swimmers. Or land masses roamed by massive reptilian herds under skies filled with flying creatures of immense wingspans. Within such environments, life would have followed its persistent drive toward complexity, producing nervous systems capable of modeling the world, then minds able to plan beyond immediate survival, eventually yielding beings who fashioned tools, mastered fire, formed cooperative groups, and began the long acceleration toward technological transformation. Their path would mirror ours in fundamental ways because the underlying physics and chemistry of this planet remain constant. Energy stored in ancient biological remains offers dense, portable power. Metals buried in ores provide conductors and structural strength. The atmosphere and oceans act as both resources and waste sinks until thresholds are crossed. Starting from simple beginnings, sharpened stones, controlled flames, basic shelters, these societies would accumulate knowledge across generations, discovering ways to harness water flows, capture wind, concentrate solar heat, and eventually tap the vast reserves of buried fuels that nature had compressed over previous eras. Growth would feel exponential once certain thresholds were passed. Population increases enabled by reliable food, division of labor freeing minds for invention, networks of trade and communication spreading innovations rapidly. Cities would emerge, suited to their biology and materials, perhaps vast mound complexes of engineered soil, crystalline structures grown from mineral solutions, or sprawling networks of tunnels and chambers deep underground to escape surface extremes. Machines would multiply, mechanisms for lifting and moving, for processing materials at scale, for extending senses across distances, eventually leading to powered transport, artificial illumination, and global connectivity. As their reach expanded, the same temptations we face today would arise. Abundance encourages further extraction. Waste seems manageable when dispersed into vast air and water volumes. Short-term gains outweigh long-term risks when survival pressures linger in cultural memory. They would release gases that trap heat, initially as byproduct, then deliberately for energy, warming the world beyond natural cycles and triggering feedbacks in ice melt, ocean circulation, and storm intensity. Oceans would absorb excess gases, growing more acidic and less hospitable to shell-forming life. Nutrients from eroded lands or deliberate runoff would fuel massive blooms followed by dead zones. Materials refined and spread would settle everywhere, from mountain tops to deep sea floors. Some among them would surely recognize the patterns, observers tracking changing seasons, chemists noting shifting air composition, ecologists watching species retreats, much as we do now with satellites, ice cores, and ocean buoys. Debates would parallel ours, voices urging restraint and balance against those advocating innovation to solve emerging problems, promises of cleaner energy just beyond the horizon, beliefs that relocation or engineering could outpace consequences. The echoes preserved in the rock record suggest that continuation generally prevailed until momentum became unstoppable, leading to the rapid pulses we detect: concentrated carbon inputs, staged ocean crises, clustered material depositions, all indicating societies that scaled to planetary influence before internal or external limits forced reduction. Collapse would not necessarily mean total extinction. More likely, it involved fragmentation into smaller, simpler groups, loss of complex infrastructure, retreat to sustainable but low-energy ways of living, with direct artifacts crumbling under vegetation, erosion, and burial over subsequent ages. Knowledge would fragment, preserved perhaps in oral traditions or isolated enclaves before fading entirely, leaving no clear writings or monuments for us to find, because plate tectonics, glaciation, and sedimentation relentlessly recycle the surface. What endures are only the side effects that operate on global scales, the climate excursions that alter sedimentary chemistry worldwide, the material spreads that create detectable enrichments even after dilution, the ocean shifts that leave fossil and isotopic records in widespread deposits. Multiple such pulses across different eras support the idea of separate attempts rather than one long dominant lineage, societies arising when conditions favored abundant energy and stable climates, expanding aggressively, then receding when consequences mounted, allowing recovery intervals during which life diversified anew. Different biologies could have achieved this: warm-adapted reptilian forms in greenhouse worlds, avian descendants in cooler periods, or entirely unfamiliar body plans we can barely reconstruct from fragmentary fossils. Each would develop technologies fitted to their physiology and environment, perhaps biochemical rather than mechanical in some cases, sonic or electromagnetic communication in others, yet all would face the same planetary boundaries: finite concentrated fuels, sensitive atmospheric balances, interconnected ecosystems vulnerable to rapid perturbation. Their fates would vary, some declining gradually through resource exhaustion and social simplification, others tipping quickly into climate runaway or waste overload, a few perhaps achieving partial sustainability before external events like impacts or massive volcanism delivered final blows. This imagined reconstruction carries emotional weight because it humanizes, or rather, intelligentizes, the possibility, making predecessors not abstract anomalies but relatable actors who dreamed, built, argued, and ultimately yielded to limits most could not collectively overcome. We inherit their recovered world, soils replenished after ancient exhaustion, oceans reoxygenated after dead zones healed, atmospheres stabilized after excursions faded, buried fuels accumulated anew from post-collapse biological productivity. Our own rise benefits directly from this renewal, yet follows the same trajectory, extracting those stored energies rapidly, spreading refined materials globally, altering climate and ocean chemistry in patterns that match the ancient signatures with unsettling precision. The difference lies in our emerging awareness. Modern tools let us read the echoes they could not. Global networks allow coordinated response they may have lacked. Accumulated scientific understanding offers pathways to decoupling growth from depletion that they never discovered or implemented. Recent modeling efforts reinforce this perspective by simulating hypothetical industrial trajectories overlaid on real paleoclimate data, revealing that several ancient events fit societal rise and fall scenarios better than some purely natural explanations, particularly in the multi-phase structure of disturbances. Initial gradual warming accelerating into sharp peaks, partial recoveries interrupted by renewed inputs, final collapses followed by long stabilization. Biological evidence complements this. Major evolutionary innovations and diversity explosions often follow the crises, as if mass retreats cleared ecological space for rapid experimentation, with intelligence emerging as one successful strategy in the aftermath. Our lineage traces through such a post-crisis window, small adaptable mammals surviving shadows, to eventually produce tool users capable of reconstructing the very events that shaped our opportunity. The philosophical and existential implications deepen here. If we are not the first, then intelligence is not life's singular goal, but a recurring phenomenon, a persistent way for complex systems to reflect upon and transform their environment, yet one that carries inherent risk of self-limitation through planetary feedback. This view aligns with broader questions about cosmic silence. Despite countless habitable worlds, we detect no obvious technological neighbors, suggesting that sustainability at scale may be the rarest achievement, with most attempts remaining brief and local, their traces confined to home planets and eventually erased. Earth then becomes not an outlier in isolation, but a typical case study in life's repeated experimentation with awareness, where cycles of rise and reset dominate because managing planetary boundaries proves harder than reaching them. Yet this recognition offers something unprecedented, the chance to observe the pattern from within and choose differently, to prioritize circular resource flows, renewable energy capture, waste minimization, and global cooperation before thresholds are irreversibly crossed. Whether we seize this opportunity remains open, but the accumulating evidence from deep time transforms the question from speculative wonder into urgent inquiry, reminding us that longevity is not guaranteed by intelligence alone, but earned through restraint and foresight. As we continue this journey, the focus widens beyond Earth's hidden past to encompass future possibilities. Technologies emerging today that could confirm or refute these signals, missions planned to probe deeper records, and pathways humanity might take to either repeat the ancient rhythm or finally step beyond it into sustained presence. Having sketched the plausible outlines of predecessor societies, their emergence from diverse biological foundations, their acceleration through energy mastery and material transformation, their expansion to planetary scales, followed by inevitable confrontation with limits and eventual reduction, leaving only diffused echoes in the geological record, we now find the perspective widening dramatically. Encompassing not just isolated events or individual cycles, but the entire sweeping arc of life's history on this planet as a recurring pattern of complexity building, intelligent awakening, rapid reshaping, and subsequent reset. This broader view reveals Earth's story as one of persistent experimentation rather than linear progress toward a singular goal, where life repeatedly explores greater organization and awareness, occasionally producing minds capable of deliberate planetary alteration, yet rarely, if ever, sustaining that alteration indefinitely without triggering feedbacks that force simplification and renewal. The great mass retreats and diversity explosions that punctuate the fossil record take on new meaning in this light, not merely random catastrophes driven by external impacts or internal volcanic upheavals, but potential aftermaths of internal overshoots, where intelligent activity amplified natural variabilities until ecosystems tipped, populations crashed, and survivors inherited cleared spaces for fresh evolutionary trials. Across billions of years, life has bloomed in myriad forms: microbial mats covering oceans, vast forests of strange trees under alien skies, seas teeming with shelled creatures, lands dominated by gigantic herbivores and predators, each era building complexity until disruptions pruned back the branches, allowing new growth from remaining roots. The repeating disturbances we have traced, with their characteristic rapid carbon infusions, ocean chemistry shifts, and material mobilizations, occur at key junctures within this larger rhythm, often just before or during major biological transitions, as if the planetary stresses coincident with intelligent-scale activity not only ended one phase but fertilized the conditions for the next. Intelligence itself emerges as a recurrent strategy rather than a unique endpoint, a way for living systems to model futures, coordinate actions, harness concentrated energy, and extend reach, yet one that inherently accelerates resource flows and waste cycles to speeds the biosphere struggles to absorb. Our own appearance fits seamlessly into this pattern. We arise in the wake of a prior crisis that cleared mammalian paths, exploit renewed abundances of stored ancient fuels, spread refined materials and altered chemistries globally, and now approach thresholds whose signatures match those preserved from earlier episodes with striking fidelity. This cyclic interpretation gains support from increasingly sophisticated modeling efforts, where researchers simulate hypothetical societal trajectories, population growth curves, energy consumption escalations, waste release patterns, climate response feedbacks, and overlay them onto real paleodata, finding that multiple ancient events exhibit phased structures more consistent with guided intensification than purely stochastic natural forcing. Initial gradual changes accelerate into sharp peaks as if driven by deliberate expansion, followed by stuttering attempts at stabilization, perhaps reflecting societal adaptations or partial restraints, before final overwhelming releases tip systems into collapse and long recovery. Biological evidence aligns closely. The most profound evolutionary leaps, from microbial oxygenation of the atmosphere to the explosion of complex animals or the rise of large-brain tool users, frequently follow these disturbance intervals, suggesting that the bottlenecks and empty niches created by widespread disruption provide fertile ground for rapid innovation, with self-aware intelligence proving an effective survival and expansion tool in multiple post-reset environments. Our lineage benefits from exactly such a window, emerging from small, adaptable survivors of a previous die-off to gradually dominate a healed world rich in untapped resources, yet now replicating the same acceleration that may have characterized earlier attempts. The recognition of this deeper rhythm profoundly alters our self-understanding. Humanity no longer stands as life's crowning achievement or inevitable destination, but as the latest expression of a persistent phenomenon, one where reflective intelligence arises periodically when energy abundance and ecological opportunity align, transforms its surroundings dramatically, and then typically recedes as planetary boundaries reassert themselves. This perspective resonates strongly with the broader cosmic puzzle that has long troubled astronomers and philosophers alike: the apparent silence amid vast numbers of potentially habitable worlds, where simple probability suggests technological societies should be commonplace, yet we detect no clear signals, no visiting probes, no unmistakable engineering on distant systems. If Earth's history reflects a common dynamic, then the silence makes sense not as evidence of rarity, but of brevity. Civilizations flare brightly on their home planets, reach planetary influence, alter surfaces and atmospheres visibly for a geological instant, then fade through self-limitation or catastrophe, leaving worlds that heal over millions of years and try again with new variations. Traces remain local and eventually erased by the same active geologies that recycle crusts and atmospheres, confining evidence to the planet of origin while the cosmos returns to quiet waiting. Earth then serves as a representative case rather than an exception, a world where life persistently complexifies, intelligence emerges multiple times as an effective but risky strategy, and sustainability proves elusive because the same traits that enable rapid ascent, foresight, cooperation, innovation, also fuel expansion beyond renewable flows until feedbacks dominate. Predecessors would have faced identical great filters, not in the leap to space, but in the management of homeworld dynamics, transitioning from concentrated buried fuels to perpetual renewable capture, balancing growth with regeneration, achieving global coordination before local conflicts or uneven resource access fracture unity, containing waste cycles before they alter climates irreversibly. Most attempts, judging from the diffused pulses in our record, navigated these filters incompletely, achieving heights sufficient to leave planetary scars, but not the equilibrium needed for endurance, allowing life to reset and produce subsequent trials, including ours. The absence of constant industrial signatures across all geological eras argues against any single lineage maintaining dominance indefinitely, instead favoring episodic rises separated by long intervals of simpler living, healing, and biological diversification. Yet our position within the cycle introduces something potentially novel: the capacity to discern the pattern itself through accumulated records and global analysis, offering awareness that earlier societies likely lacked or could not act upon collectively. We map ancient echoes with tools they never possessed: satellites tracking current changes against paleoproxies, ice cores preserving air compositions across ages, deep-sea sediments revealing ocean histories layer by layer, building models that forecast outcomes and test interventions before thresholds are crossed. This meta-awareness, enabled by the very connectivity and knowledge-sharing that characterize our expansion, presents an opportunity to decouple intelligence from inevitable overshoot, to shift toward energy systems that mimic natural flows, design materials that cycle rather than accumulate, restore ecosystems as integral partners rather than resources to exploit, and foster cooperation that prioritizes shared longevity over competitive gain. Whether this opportunity translates into sustained presence remains the open question of our era, but the evidence from deep time elevates it from abstract ethics to practical necessity, transforming inherited warnings into actionable maps. As research progresses, the cyclic view gains indirect support from negative evidence as well. Vast stretches of the record show no industrial-like anomalies, consistent with long recovery periods where life operated within natural energy budgets, building complexity slowly without triggering global disturbances. When pulses do appear, their limited duration and separation align with societies that rose aggressively, but could not transition smoothly to equilibrium, perhaps exhausting easy fuels before mastering alternatives, or fracturing socially before achieving planetary stewardship. The philosophical shift is profound. Purpose in the universe no longer centers on producing one enduring technological lineage, but on exploring the possibilities of awareness itself, with intelligence serving as life's way of reflecting upon and experimenting with its own dynamics, often discovering limits through direct experience. This humbles our ambitions while clarifying the challenge, sustainability not as restriction, but as the highest expression of intelligent design, aligning technological creativity with planetary rhythms rather than overriding them. The journey now carries us toward future horizons, emerging technologies that could probe deeper for confirmatory signals or rule them out decisively, plan missions to untouched sediments or polar vaults, advanced simulations testing sustainability pathways against ancient templates. More crucially, it focuses on our own unfolding choices, whether to follow the familiar arc toward another diffused echo or to forge the first sustained chapter, potentially extending traces beyond planetary erasure through careful stewardship or eventual reach to other worlds. The silence of the cosmos may not be emptiness, but a vast field of quiet recoveries and new attempts, with Earth currently in an active phase where awareness of the broader pattern offers a rare chance to achieve endurance. As we stand amid accelerating change that mirrors ancient signatures, the echoes from deep time speak not with certainty, but with urgent clarity. The cycle is real, the risks are proven, the opportunity is ours. As the cyclic pattern of rise, transformation, collapse, and renewal comes into sharper focus across Earth's vast timeline, revealed through the converging echoes of repeated disturbances, material spreads, ocean shifts, and post-crisis biological explosions that align too precisely with what intelligence-scale activity would produce, we arrive at the heart of the larger picture, where the Silurian Hypothesis evolves from a cautious thought experiment into a comprehensive framework that explains not only the anomalies, but the very structure of life's persistence on this planet. This framework posits that intelligence capable of planetary reshaping has emerged multiple times, not as isolated anomalies, but as natural outcomes when abundant energy, stable climates, and ecological openings coincide, allowing societies to scale rapidly before confronting the inherent limits of a finite world, triggering resets that clear space for new attempts while leaving only indirect, diffused signatures blended into the geological narrative. The theory accounts for the absence of direct artifacts, no preserved cities, machines, or monuments, by emphasizing the relentless recycling power of plate tectonics, erosion, glaciation, and sedimentation, processes that erase surface traces over millions of years while preserving global side effects like atmospheric excursions, oceanic chemistry alterations, and widespread material enrichments that we have traditionally attributed entirely to natural volcanism, methane releases, or orbital variations. Alternative explanations certainly exist and remain the scientific mainstream. Every individual disturbance can be fully accounted for by known natural mechanisms. Massive flood basalts pouring gases over extended periods, sudden destabilization of frozen seabed stores under warming pressure, asteroid impacts delivering energy and materials, or long-term shifts in continental configurations blocking ocean currents and altering climate belts. These alternatives fit the data cleanly in most cases, require no additional actors, and align with the principle of parsimony that guides research, preferring the simplest interpretation until evidence demands otherwise. Problems arise, however, when examining the collective pattern. The precise pacing of multi-phase inputs that suggest guided acceleration rather than random forcing, the consistent clustering of lighter carbon signatures and metal mobilizations around biological transition points, the subtle molecular fragments and land use signals that deviate from pure natural baselines in ways models struggle to replicate without invoking concentrated, deliberate release. While no single anomaly overturns natural causes, the repetition across separated eras builds a cumulative case that the Silurian framework addresses more cohesively, proposing that occasional intelligent amplification of natural variabilities tips systems past recovery thresholds, producing the observed crises as hybrid events, part geological, part societal consequence. Key figures in this developing discussion include the original authors of the hypothesis, climate modelers and astrophysicists who first framed the question systematically, alongside paleoclimatologists, geochemists, and evolutionary biologists from leading institutions who have since refined the search for distinguishing signals through higher resolution proxies and advanced simulations. Collaborations now span universities and research centers focused on Earth's deep history, exoplanet habitability, and sustainability science, with interdisciplinary teams compiling databases of potential technosignature-like anomalies, testing them against null hypotheses of pure natural variation, and publishing findings that increasingly highlight statistical deviations worth further pursuit. These researchers stress caution repeatedly. No claims of confirmed predecessors, only the recognition that our detection limits are severe over geological timescales, and that systematic blindness to artificial possibilities may have obscured patterns hiding in plain sight. Philosophical and existential consequences flow naturally from this shift. Humanity's sense of exceptionalism erodes as intelligence reveals itself not as life's ultimate purpose, but as a recurring tool for exploration and transformation, one that carries built-in risks of self-correction through planetary feedback, forcing us to reconsider free will, progress, and destiny within a cosmos where awareness arises often, yet endures rarely. This reframing forces us to rethink the foundations of existence itself, what it means to be a thinking species on a world that may have hosted others, inheriting their renewed abundances while repeating their trajectories. The uniqueness we claim dissolves into pattern recognition. Life persistently seeks greater complexity and reflection, producing minds that reshape environments to extend survival and comfort, yet those reshapings accumulate consequences that eventually demand simplification. If predecessors navigated similar awakenings, discovering energy stores, building networks, debating futures, they likely grappled with parallel questions of meaning, legacy, and responsibility, perhaps developing philosophies or spiritual frameworks to justify expansion or urge restraint, only to see collective momentum favor growth until limits asserted themselves. Our own cultural narratives of endless progress, manifest destiny, technological salvation, echo what theirs might have been, making the ancient echoes feel like distant mirrors reflecting our current dilemmas with unsettling clarity. The hypothesis thus challenges not just scientific models, but worldview foundations. Are we protagonists in a singular story, or participants in a larger, impersonal dynamic where intelligence serves life's broader experimentation rather than dominating it permanently? Existential weight deepens when connecting this terrestrial cycle to the cosmic scale already touched upon, the profound silence we observe despite billions of potentially life-friendly worlds orbiting distant stars. If Earth's record reflects a common process, then brief technological windows explain the absence of detectable neighbors. Societies reach planetary influence, alter their homes visibly for short geological periods, then recede, allowing healing and new trials while traces remain confined and eventually erased. Signals sent outward fade over distance and time. Outposts or probes fail without sustained support. Megastructures prove impractical before collapse intervenes. The great filters constraining cosmic company lie not primarily in life's origins or intelligence's emergence, both seemingly achievable given favorable conditions, but in the sustained management of planetary systems, where exponential tendencies clash with finite boundaries. Predecessors on Earth would have faced these filters locally, succeeding in ascent but failing endurance, leaving us to confront the same tests with the added burden or gift of partial foresight derived from their diffused legacies. This larger picture transforms urgency into opportunity. Unlike earlier attempts, we possess tools to map the cycle comprehensively, global observing networks tracking changes in real time against ancient proxies, computational models forecasting outcomes under varied scenarios, communication systems enabling coordinated response across cultures. These capabilities, products of our own expansion phase, offer pathways to transition beyond buried fuels toward perpetual renewable capture, to design closed-loop material flows that minimize waste accumulation, to restore ecosystems as active partners in stabilization, to prioritize equity and long-term thinking in governance. The theory does not predict inevitable collapse, but highlights the narrowness of sustainable paths, emphasizing that longevity requires deliberate alignment with planetary rhythms rather than override attempts. Recent breakthroughs in proxy resolution and simulation sophistication lend weight here. Finer isotopic readings reveal subphases within crises that models of societal response replicate better than some natural-only scenarios, while negative evidence from undisturbed eras confirms long intervals of balance consistent with post-reset healing. As the framework solidifies, it bridges terrestrial deep time with forward-looking inquiry. What technologies emerging today could probe remaining ambiguities decisively? What missions might access untouched records preserved in polar ice, deep seabeds, or mantle-derived samples? What societal choices could extend our chapter beyond the familiar arc? The Silurian Hypothesis, once a provocative edge question, now anchors a unifying lens that explains anomalies, biological transitions, cosmic silence, and our own precarious moment in one coherent narrative, forcing us to confront whether intelligence's highest expression lies in domination or harmony, in brief brilliance or enduring presence. The philosophical recalibration is total, existence not as ascent toward mastery, but as participation in life's ongoing self-discovery, where awareness offers the rare chance to observe limits and choose transcendence over repetition. With this big picture assembled, the path ahead leads naturally toward practical horizons, current and near-future efforts to test the theory rigorously, potential discoveries that could confirm or refute it, and the profound implications for humanity's immediate choices amid accelerating change. With the larger picture now fully assembled, the Silurian Hypothesis providing a unifying lens that ties together the recurring geological anomalies, the patterns of biological transition, the cosmic silence, and our own precarious moment of acceleration, we turn naturally toward the horizon of what comes next, toward the concrete efforts underway today that could sharpen this framework into confirmed understanding or refine it into a more limited cautionary tool. Modern science stands at an unprecedented threshold, equipped with technologies that allow us to probe Earth's deep memory with finer resolution than ever before, to model complex planetary systems with increasing accuracy, and to compare our world against distant exoplanets where similar cycles might be playing out in real time. These advancing capabilities offer genuine prospects for answers in the coming years and decades, not through dramatic unearthing of ancient machines, which time has rendered unlikely, but through systematic detection of subtle deviations that either accumulate into compelling evidence for predecessor activity or solidify the case for purely natural explanations across all events. Recent breakthroughs in proxy development, computational power, and interdisciplinary collaboration give us solid grounds to expect meaningful progress, potentially transforming the hypothesis from provocative speculation into a tested component of Earth's history, with profound ripple effects on how we approach sustainability, exploration, and our place in the cosmos. Central to this forward push are ongoing and planned missions focused on accessing pristine records preserved in Earth's most stable archives, the deep ocean floors, polar ice sheets, and undisturbed continental sediments where recycling processes have been minimal. International drilling programs continue to pull longer, higher-quality cores from seabed sites that span critical disturbance intervals, revealing layered chemistries at resolutions that capture decade-scale or even year-scale variations, rather than the broader millennial averages of older samples. These cores preserve trapped gases, microfossils, and isotopic ratios that can distinguish concentrated release events from gradual natural seepage, potentially identifying signatures of rapid, societal-scale inputs that models predict for industrial phases. Complementary efforts in Antarctic and Greenland ice drilling target bubbles of ancient air sealed during key warm periods, offering direct snapshots of atmospheric composition that bypass sedimentary alterations and allow precise tracing of carbon sources, whether volcanic, biological, or combustion-derived. Advances in mass spectrometry and laser-based extraction now resolve these bubbles at parts per billion sensitivity, revealing minor components like trace industrial pollutants or unusual noble gas ratios that could deviate from expected natural baselines if artificial processes contributed. On land, seismic surveys and strategic borehole campaigns map buried landscapes beneath overlying deposits, identifying potential sealed pockets or anomalous structures that warrant targeted excavation, while remote sensing from satellites refines surface mapping to pinpoint sites least affected by erosion or tectonics. Artificial intelligence plays an accelerating role here. Machine learning algorithms trained on vast paleodata archives now scan for statistical outliers across thousands of records simultaneously, flagging correlations in carbon excursions, metal enrichments, and biological shifts that human eyes might overlook, then generating testable hypotheses for focused follow-up. These tools have already uncovered subtle sub-patterns within well-studied events, multi-century pulses nested inside larger crises, that align better with scenarios of societal response and adaptation than with uninterrupted natural forcing, fueling proposals for dedicated anomaly hunting initiatives across multiple institutions. Collaborative networks now link geochemists, climate modelers, astrobiologists, and data scientists in shared platforms that integrate diverse proxies into unified reconstructions, simulating not just climates but hypothetical resource extraction cycles, waste dispersion pathways, and ecosystem responses to guided perturbation. Beyond Earth-bound efforts, space-based observatories contribute indirectly yet powerfully by characterizing exoplanets in ways that inform what planetary-scale activity looks like from afar, helping calibrate what traces might endure or vanish over cosmic timescales. Next-generation telescopes now resolving atmospheric spectra of rocky worlds in habitable zones search for biosignatures and technosignatures alike, unusual gas balances that could indicate either biological flourishing or industrial alteration, providing comparative data that sharpens our understanding of how Earth's own signatures would appear to distant observers during different phases of potential cycles. Missions studying Venus and Mars probe extreme greenhouse outcomes and lost habitability, offering cautionary analogs for runaway feedbacks that predecessors might have triggered, while lunar and asteroid sample returns refine impact chronologies that sometimes overlap with terrestrial disturbances, clarifying external versus internal contributions. These cosmic perspectives feed back into terrestrial models, testing whether Earth's repeated crises fit a common profile for life-bearing worlds where intelligence emerges but struggles with sustainability. Breakthroughs in the last decade, particularly in isotopic fractionation analysis, molecular paleontology, and high-performance computing, give genuine cause for optimism that key questions could see substantial clarification within our lifetimes. Improved dating techniques now resolve event timings to within centuries rather than millennia, revealing whether material mobilizations precede, coincide with, or follow climate shifts in ways predictable from societal expansion models. Synthetic aperture radar and gravimetric satellites map subsurface densities that hint at large-scale ancient modifications, guiding ground truth expeditions, while laboratory experiments recreating high-pressure mineral alterations test whether observed enrichments require artificial processing conditions. As these threads converge, possible discoveries loom, a cluster of anomalies resisting all natural explanations, or conversely, refined models closing gaps to confirm purely geological origins across the board. Either outcome carries weight, the former reshaping history and urgency, the latter freeing focus onto our unique responsibilities without precedent shadows. The scale escalates here to its cosmic maximum. If the hypothesis holds even partially, Earth exemplifies a widespread dynamic where life routinely achieves awareness, yet rarely sustains it, producing brief technological windows scattered across galaxies like sparks in vast night. Silent skies then reflect not absence but recovery, worlds healing after their own cycles, waiting for new blooms while any enduring societies remain exceptionally rare, perhaps separated by distances or strategies we cannot yet detect. Our accelerating capabilities, fusion energy prototypes, global carbon monitoring networks, regenerative ecosystem projects, position us at a pivotal branch point, to either join the diffused echoes or pioneer the first sustained chapter, potentially announcing endurance through deliberate signals or careful stewardship that preserves habitability across ages. Recent progress in renewable transition modeling, circular economy implementation, and international cooperation frameworks offers tangible paths forward, demonstrating that alignment with planetary limits is achievable with collective will guided by the very evidence emerging from deep time. This forward horizon narrows the existential questions to immediate relevance. Technologies now maturing could not only test the hypothesis decisively, but illuminate viable longevity strategies, turning ancient warnings into practical blueprints. As drilling ships prepare for deeper seabeds, as algorithms sift ever larger datasets, as space telescopes multiply their targets, the next decades promise breakthroughs that clarify whether we follow a recurring rhythm or finally compose a new one. The stakes encompass everything: history's interpretation, future's direction, cosmos's character, making this moment not merely observational but participatory, where scientific advance and societal choice intertwine to determine whether intelligence on Earth remains episodic or becomes enduring. With these prospects unfolding, the deepest implications surface next. The profound ways this possibility reshapes reality's understanding, the unresolved paradoxes that linger, the varied scenarios for our trajectory, and the ultimate questions tying terrestrial cycles to universal patterns. The deepest implications of this possibility surface when we step back and allow the full weight of the Silurian framework to settle over our understanding of reality itself. A reality no longer anchored in the comforting certainty that humanity represents life's first and only attempt at reflective, transformative intelligence on this planet. If predecessors rose and receded multiple times, leaving their planetary scars blended into what we have long read as purely natural history, then the very fabric of existence shifts beneath us. Time becomes not a linear path leading inevitably to us, but a vast, looping tapestry where awareness emerges, reshapes the world, confronts limits, and often yields to renewal, making our moment feel both profoundly ordinary and achingly precarious. The ground of being once solid with assumptions of uniqueness, purpose directed toward a single technological lineage, reveals itself as fluid, cyclical, governed by persistent life forces that experiment with complexity again and again, producing minds not as endpoints but as transient tools for exploration, capable of profound creation, yet vulnerable to the same feedbacks that prune overgrowth in any ecosystem. This realization dissolves the illusion of separation. We are not apart from nature's rhythms, but deeply embedded within them, our cities and machines extensions of the same creative impulse that may have built and abandoned earlier works, our wastes and alterations echoes of prior disturbances that healed only after reduction. Reality reconfigures around impermanence at scale, civilizations not as permanent triumphs, but as intense, temporary blooms within life's broader garden, flourishing brightly when conditions align before seasonal limits force retreat, allowing soil to regenerate for future growth. The human experience, with its aspirations toward eternity through legacy, exploration, or transcendence, confronts a mirror in the rocks. Dreams pursued with fervor, structures raised against entropy, knowledge accumulated across generations, only to dissolve under time's patient hand, leaving indirect traces that later eyes might misread or overlook entirely. This perspective alters everything. Science becomes not just discovery, but archaeology of potential kin, history not merely human chronicle but planetary biography marked by unseen chapters, philosophy not abstract inquiry but urgent dialogue with absent voices whose fates whisper consequences. The cosmos, once imagined as empty stage awaiting our entrance, fills with quiet parallels, countless worlds likely hosting similar cycles, brief windows of awareness scattered like fireflies in endless night, their lights winking out as planetary balances reassert themselves, explaining the silence not as absence of company, but as rarity of endurance. Unresolved paradoxes linger at the edges, sharpening the tension rather than resolving it cleanly. Chief among them is the detection paradox. If predecessors achieved planetary scale, why do we find no clear, unambiguous signatures, no durable artifacts in stable settings, no signals embedded in lunar regolith or asteroid surfaces, no genetic or cultural fragments persisting through recovery intervals? Yet the indirect echoes align so precisely with what we would expect from erased activity. Natural explanations close most gaps individually, yet the collective repetition strains coincidence, suggesting either remarkable consistency in geological forcing or subtle contributions we lack tools to isolate definitively. Another paradox concerns biological continuity. Life rebounds with explosive innovation after each crisis, producing greater complexity and eventually intelligence anew. But if predecessors altered ecosystems profoundly, why no lingering synthetic markers or engineered traits in modern lineages? Unless healing processes proved thorough enough to purge all but the broadest chemical scars, or unless societies collapsed before achieving deep biological manipulation. The cosmic paradox deepens this. If cycles are common, sustained civilizations should be detectable somewhere through megastructures or atmospheric engineering, yet searches yield nothing conclusive, forcing us to question whether endurance requires invisibility, low-impact harmony indistinguishable from nature, or whether the filters simply prove insurmountable for nearly all who reach our threshold. These paradoxes connect outward to broader cosmic phenomena, weaving the Silurian lens into the fabric of astrobiology and exoplanet study. Transient atmospheric anomalies detected on distant worlds, sudden gas imbalances that appear and fade, might reflect similar brief industrial phases rather than permanent biospheres or technospheres, aligning with Earth's pulsed record and explaining why habitable zones seem lively yet quiet on technological scales. Great extinctions here mirror potential die-offs elsewhere triggered by internal overshoots rather than solely external impacts, suggesting life's resilience lies in reset capacity rather than unbroken stability. The Fermi question, where are they, resolves into temporal dispersion. Neighbors exist but separated by recovery phases, their signals long faded or never strong enough to bridge gulfs before collapse intervened. Dark forest hypotheses or zoo scenarios fade against this simpler dynamic. Most awareness remains local and short-lived, confined by homeworld management challenges before interstellar reach becomes feasible. From these depths emerge possible scenarios for humanity's path, each grounded in the evidence, yet branching into bold but scientifically plausible futures that extend the cycle or break it. First scenario, continuation of the familiar arc. Exponential expansion driven by abundant remaining fuels and innovation momentum overrides early warnings, amplifying current disturbances into full crisis, triggering reduction through climate feedbacks, resource conflicts, or ecosystem collapse, leaving our layer as another diffused pulse that future survivors read as natural, with life recovering over ages to try anew. Second scenario, partial awakening. Recognition of patterns spurs widespread but uneven restraint, achieving regional sustainability while global inequities and legacy systems delay full transition, resulting in prolonged stress followed by managed decline, preserving knowledge fragments through enclaves that seed simpler, balanced ways, extending presence but at reduced scale. Third scenario, deliberate transcendence, coordinated global shift toward renewable flows, circular materials, ecosystem restoration, and equitable governance aligns intelligence with planetary limits, stabilizing habitability and allowing gradual extension beyond Earth through careful colonization or signaling, marking the first sustained chapter where awareness endures without self-erasure. Fourth scenario, external interruption. An asteroid, supervolcano, or solar fluctuation compounds our alterations unpredictably, accelerating reset regardless of choices, reminding that cosmic forces remain wildcards even for aware species. The most profound conclusions crystallize when we hold these scenarios together. Intelligence offers no exemption from nature's rhythms, but the potential to navigate them consciously, turning recurrent risk into chosen harmony. If predecessors faced similar branches and chose paths leading to echoes, their indirect legacy becomes guidance, proof that ascent is achievable yet endurance demands alignment, that brilliance alone does not guarantee longevity, but wisdom in restraint might. Reality, under this light, reveals itself as participatory. We do not merely observe cycles, but inhabit a moment where observation enables intervention, where understanding ancient whispers could compose the first melody that persists beyond seasonal change. The culmination approaches, not in certainty of predecessors' existence, but in clarity of consequence. Whether proven or refined away, the inquiry reshapes us, making sustainability not optional ethic but essential expression of aware life, the bridge from episodic flare to enduring light. As this peak nears, the path winds toward synthesis, recapping the journey from initial provocation through accumulating clues, theoretical framing, future prospects, and now these deepest reverberations that touch existence's core. The echoes no longer whisper but resonate, urging not fear but resolve, not despair but determination to author an outcome different from the diffused past. The final questions loom. What will our layer say to those who follow? Natural catastrophe or deliberate balance? And can awareness finally prove greater than its own momentum? The resonance of those ancient echoes now fills every corner of consideration, shaping not just intellectual understanding, but the felt sense of existence. How we move through days, make choices, look at the night sky or the ground beneath cities, knowing that the planet may carry memories of other minds who once stood in similar wonder and urgency. The four scenarios outlined: familiar continuation into crisis, partial awakening yielding managed decline, deliberate transcendence through aligned stewardship, or external interruption compounding our trajectory, do not stand as abstract possibilities, but as living branches extending from this moment, each rooted in the evidence accumulating from deep time and each carrying distinct consequences for what our layer in the rocks will ultimately say. The most haunting among them, the continuation of the established arc, feels closest because it requires no radical shift. Momentum built from centuries of extraction and innovation carries forward, amplifying current warming, ocean stress, and material spread until feedbacks overwhelm adaptation capacity, producing a disturbance pulse indistinguishable from prior ones except in finer details future analysts might decode. Life would persist through bottlenecks, survivors adapting in refugia, ecosystems rebuilding over ages, until conditions again favor complexity and eventual reemergence of awareness, perhaps in forms better suited to the altered world, reading our carbon excursion and plastic-enriched sediments as another natural upheaval, never suspecting the deliberate hand that shaped it. The partial awakening scenario offers a middle path that feels achingly plausible given historical patterns of uneven progress, regions and communities embracing renewable flows, circular systems, and restorative practices, while others cling to legacy fuels and growth imperatives, creating prolonged tension where partial stabilizations buy time but global interconnections transmit stresses across boundaries. Knowledge would endure in fragments, digital archives hardened against decay, physical repositories in stable locations, oral and written traditions in resilient enclaves, seeding recovery with advantages predecessors lacked, faster rebuilding of balanced ways, preserved warnings against overreach, perhaps even genetic or cultural adaptations favoring cooperation over competition. Yet reduction would still come, scale diminishing as carrying capacity contracts, cities gradually abandoned to vegetation, infrastructures simplified to match renewable budgets, leaving a layer marked by attempted transition, sharper declines in certain pollutants mid-pulse, anomalous preservations of knowledge structures, hinting to future readers that awareness nearly broke through but fractured under its own inconsistencies. The transcendence scenario demands the boldest leap, yet carries the most profound reward: collective recognition of the cycle-spurring coordinated realignment, where energy capture mimics natural cycles, solar, wind, geothermal, biological, material flows close into loops that eliminate waste accumulation, ecosystems actively restore to enhance resilience, governance prioritizes equity and foresight over short-term extraction. This path would stabilize habitability indefinitely on Earth, allowing gradual extension outward, self-sustaining habitats on neighboring worlds, careful seeding of life where absent, deliberate signals broadcast across spectra to announce endurance rather than brief flare. Our geological layer would stand apart, disturbances peaking then reversing through visible drawdown, enrichments plateauing and dispersing naturally, biological diversity rebounding under guidance rather than collapse, clear markers of intentional management that future inhabitants, whether our descendants or new emergences, would recognize unambiguously as artificial balance. Cosmic silence might finally break, not through desperate expansion, but through patient presence, inviting contact with any others who solve the same filters, forming networks of sustained worlds sharing knowledge across ages. The interruption scenario reminds us that agency operates within larger forces. An incoming impactor, supervolcanic episode, or solar variability could compound anthropogenic stresses unpredictably, accelerating tipping points regardless of preparation level, compressing timelines and limiting choices. Predecessors may have faced similar wild cards, external events overlapping internal vulnerabilities to deliver final reductions, leaving signatures where natural and guided contributions blur completely. This possibility underscores humility. Even perfect alignment cannot guarantee absolute control, yet preparation through diversified resilience, early warning systems, and deflection capabilities expands the envelope of survivability, turning potential catastrophe into manageable risk. These scenarios converge on a central truth. The cycle evidenced in the rocks is not deterministic fate, but a default dynamic that aware intervention can redirect, with the window for redirection narrowing as momentum builds. Recent advances lend concrete hope here. Demonstrated scalability of renewable grids covering continental demands, breakthroughs in material synthesis that replace extraction with atomic precision, restoration projects reversing desertification and ocean dead zones at accelerating rates, governance experiments achieving cooperation across former divides, all showing that transcendence tools exist today, awaiting only collective will to deploy at scale. The most daring yet grounded assumption emerges. If predecessors approached similar junctions and chose continuation, their diffused legacies become not condemnation, but invitation, to recognize that intelligence capable of reading its own patterns possesses the unique potential to author endurance, turning life's recurrent experimentation into conscious evolution where awareness sustains rather than self-limits. This culmination of deep inquiry reveals the hypothesis's ultimate power. Regardless of final confirmation, the disciplined consideration of predecessor possibility recalibrates priorities, making sustainability the defining challenge of aware existence rather than optional virtue. The rocks speak not to prove lost civilizations, but to illuminate consequences, proof that planetary-scale transformation carries feedback swift enough to outpace adaptation unless foresight guides restraint. Reality viewed through this lens becomes dynamic partnership, humanity not conqueror of nature but participant in its rhythms, with intelligence the rare capacity to observe, understand, and harmonize rather than override. The journey through evidence, theory, prospects, and implications now approaches synthesis, ready to trace back the path from initial provocation to this transformed perspective, honoring what we have learned while acknowledging enduring mysteries, grounding in current consensus, and closing with the boundless invitation that vast time and space extend to any who choose sustained presence. We have traveled far together through this hidden history of our own world. From that first quiet moment holding an ancient stone, wondering what secrets it might keep beyond the natural ones we always assumed, to the deepening patterns of repeated disturbances, sudden warmings, struggling oceans, scattered materials, faint molecular echoes, all clustering around moments when life retreated and then exploded anew. We followed the careful reasoning of scientists who dared to ask whether these patterns could carry the diffused marks of earlier intelligent hands, societies that rose when conditions allowed, transformed the planet on vast scales, and then receded as consequences mounted, leaving only indirect scars we have long read as purely natural upheavals. The Silurian Hypothesis emerged not as wild claim, but as disciplined framework, explaining the anomalies, the biological transitions, the cosmic silence, and our own accelerating trajectory in one coherent arc. Life persistently experiments with awareness, producing minds that reshape environments yet rarely sustain the reshaping without triggering renewal. Along the way, we imagined those predecessors, not mythical beings but plausible societies suited to their eras, harnessing buried energies, building networks, debating futures much as we do, reaching planetary influence before limits closed in through climate feedbacks, resource exhaustion, or fractured unity. We explored accumulating clues from deeper cores and finer tools, future missions poised to probe untouched archives, and the profound ways this possibility reframes reality, from linear progress to recurring cycles, from unique destiny to participatory rhythm, where intelligence offers no exemption but the chance to harmonize. The paradoxes sharpen the view. Detection limits that erase direct traces yet preserve global echoes, biological resilience that heals completely after reduction, cosmic quiet that fits brief windows rather than enduring presence. Scenarios branched before us, continuation into another diffused pulse, partial awakening yielding managed simplicity, deliberate alignment achieving sustained harmony, or external forces compounding whatever path we choose, each grounded in the evidence yet open to our unfolding decisions. What we have learned is both humbling and empowering. The rocks preserve no certain proof of predecessors, only repeating patterns that fit their possibility with unsettling precision, reminding us that planetary-scale transformation carries built-in corrections swift enough to outpace unchecked momentum. Earth's long memory speaks of resilience, not in unbroken dominance, but in persistent renewal, clearing space for fresh attempts when overreach tips balances. Our moment stands apart because we can read these whispers with tools and perspective earlier cycles lacked, mapping risks before thresholds close, modeling alignments that decouple awareness from inevitable reset. Yet much remains veiled in mystery, whether any anomalies will resist all natural explanations decisively, whether sealed pockets preserve clearer markers, whether the cycle truly reflects universal dynamic or Earth's particular geology, whether sustainability proves achievable before momentum carries us past the point of choice. The current scientific consensus remains cautious and clear. No confirmed evidence of ancient industrial civilizations exists, with natural mechanisms fully accounting for every known disturbance through massive volcanism, frozen gas releases, orbital shifts, impacts, and continental rearrangements. The Silurian Hypothesis serves as valuable thought experiment, sharpening our search for distinguishing signals, highlighting detection limits over vast time, and underscoring the urgency of managing our own unmistakable layer before it blends into similar ambiguity. Researchers continue systematic inquiry with open minds, welcoming finer data that could refine or resolve the questions, while emphasizing that absence of obvious artifacts aligns precisely with expectations for erased activity millions of years past. We return now to that ancient stone in your hand, rough and heavy with time. It no longer feels like mere natural relic. It carries the weight of possibility, that beneath familiar ground lie echoes of other minds who once held similar stones, wondered at the same stars, built and dreamed and ultimately yielded to the planet's patient rhythms. Whether those minds truly existed or the patterns stem entirely from nature's own forces, the journey has changed how we see our place, not as isolated pinnacle, but as participants in life's vast, persistent exploration, inheritors of a world repeatedly renewed, stewards of a moment where awareness can finally choose harmony over repetition. The ground beneath us is ancient, alive, resilient. It has healed before, it can heal again. But for the first time, thinking beings can guide the healing, aligning creativity with renewal, extending presence through balance rather than dominance, turning brief bloom into enduring light. The universe is vast beyond measure, its worlds countless, its rhythms deep and patient, life's experiments endless. Our story is still being written, not in stone alone, but in choices we make today. Whatever paths we take, the journey of awareness continues, and perhaps this time it need not end.